française. Il y a Java Developer et Architector. A ja pytają учить русский. Но это очень тяжело. То, if you want, I can continue in English. Лучше. So I'm also a teacher, trainer, I wrote books, I'm a blogger. If you are interested in my books, if you who knows about the Vaadin web framework? Who? Okay, not so many people. So this is a great framework. Those who don't know, have a look at it, it's great. My latest book is about integration testing. I'm really, really interested in testing because I want to improve the quality of my applications. And today we are talking about mutation testing and how to improve your tests. So basically, you know that there are a lot of different kind of testing, right? Like 6 months ago, I stumbled upon a web page that listed about 100 kind of different testing. You have unit testing, you have integration testing, you have a shitload of performance testing kinds, you have penetration testing, exploratory testing, a lot, right? And basically, what you want to do with this kind of testing is to ensure the quality of your production code, which is great, because that's what we want in the end. However, we have a problem, because when we write unit tests, how do we check their quality, how relevant they are? Has anyone a clue about that? Code coverage, sure. Code coverage is our savior. And basically, if you look on Wikipedia on code coverage, it's the degree to which you measure how your production code is executed. So, code coverage is great. And when you run your test, you check whether a line, so this is line coverage, or branch, this is branch coverage, is executed. If it's executed, it's great. Check 1. If it's not executed, 0. And then the formula, even I can understand it. It's the number of lines executed divided by the number of total lines. Same for branches. So it's quite easy to compute, right? In Java world, who is a Java developer? Nearly everyone. Great, that's good. Love Java. In the Java world, we have a lot of tools. We have Jacoco, we had Clover, Cobertura, whatever. So we know how to compute code coverage. And if you look on the internet, because let's face it, we are a male industry. There are many males here, even in the room. There are more males than females. And males like to be better than others. So we always have to have a better code coverage than your friend, right? So what is the best code coverage? 100. And is there any possibility? Sure. No. There are no other possibility. You know Bob Martin, Uncle Bob? Who knows about Uncle Bob? So he's very well respected, very famous. And he say, sure, you have to achieve 100 code coverage. Because if you can write a line of code, of course you must test it. So there is nothing below 100. That's true. So it's done. Just achieve 100% code coverage. I have a problem with that. I think that's not because he's famous that he says only nice stuff. This is the stupidest, dumbest shit that I've ever heard. Yeah, I'm not very popular generally, but I'm straightforward. Because for me, it's very easy to achieve 100% code coverage. So I created a test. JUnit, TestNG, whatever. Easy. And I have 100%. Oh, but where is the assert? Sorry. Well, I don't care. I have 100%. So you achieved your goal, right? Now, if you want to measure against your colleague now, you see that it's completely pointless. Because code coverage is not a meaningful metric. And it's not because of code coverage itself, it's because it's a metric. So you know there is saying that if you have a goal and you set a metric to achieve it, then the metric becomes your new goal. So the only quality of code coverage is that it's easy to compute. Any idiot, even our manager, can understand it. Yeah. We are a metric-driven industry. We are engineers, so we are driven by metric. And we have to tell about metrics that people who don't know what we do, basically our manager, most of them, can understand. Code coverage is one of them. And as any metric can be gamed, you have to understand that it can be gamed on purpose, or you can fool yourself. So even if you are among a trusted group of fellow developers, then it's dangerous to believe in code coverage. And I would say that it's worse than that, because when you have 0% code coverage, you are cautious, you are wary, you take care. If you have 100% code coverage without asserts, you think that you are completely in no danger. Then you can hack anything you deploy to production and all hell breaks loose. So I prefer 0 than 100. Okay? So you have a problem? Bye? It's the end? No, I hope not. At least when I try to present a problem, I try to find a solution. And that was also my problem at some time. So I found that there is something which is quite old, actually, but called mutation testing. Okay, let's take an example. Who knows about LUDX? Okay, so let's take the example. So here, William Stryker, who in the movie is the bad guy, right? It will be our original source code, okay? And his son, who in the movie is no one, will be the mutant, right? So I've taken a stupid example. I've re-implemented the math class with the add method. Stupid, sure, but nice example. So above, there is the original source code, my implementation. And below is a mutant. And if you check, you will see that the mutant has very little change. I replace the plus by minus. Okay? So with standard testing, it goes like that. I execute my test, it runs, it's green, it should be green, and it's done. With mutation testing, you do the same, but out of the original source code, you create the mutant, you execute the same test. That is very important, the same test. You don't change your test. You just mutate your source code. And you check the results. And basically, you have two options. Either it fails, or it succeeds. If it fails, we say that the mutant has been killed. If it succeeds, we say the mutant survived. So, it's different than in a movie, right? Surviving, it's red, it's bad. Because it means that although we changed the source code, we have the same result. Okay? But if we kill the mutant, which is good, so remember, not in the movie, we kill mutants, okay? Then it means that we change the source code and then test results are different. So if I take my math class, I still have the same stuff, and here I have no assert. I have 100% code coverage. Hey, great. I execute the stuff, and what happens? My test still succeeds. Okay? Sorry, with the surviving mutant, my test still succeeds, which is bad, because we have no assert. Now think about it. Now, I will add an assert, which is good. I run my tests, so 1 plus 1 equals. Thanks, great. We are all engineers, that's good. And we do the same with the mutant, right? And now, 1 minus 1 equals 0. So it cannot be equals to 2. So it fails. That's very stupidly simple. The concept is, even I can understand that. And that's much better than before. How do we achieve that? I mean, is it only a theory, or can we do that? Sure, guys, we can do that. There is already something. There are some tools, not many, but there are some tools that provide mutation testing in Java. And the most advanced is called PIT. It's available as a command line tool. It's available as an on-target. It's available as a Maven plugin. Who uses Gradle? Wow, so many. Sorry for you guys, there is nothing for you. Sorry? Okay, use on-target. Or downgrade to Maven, which is better. Anyway, how does it work? Basically, it's very simple also. With PIT, you have mutators. And mutators are a specific kind of class that will look for a very specific pattern. And it will change this pattern. So for example, here, you can see that you have the conditional boundary mutator. So it will replace higher than by higher or equal. Okay? It will also do the same for lower than, or for lower and equals, and to lower, and stuff like that. You have the negate conditional. It will change equals equals by different from. It will remove the conditionals. A lot of stuff. And so this is how PIT works. It will apply those mutators to your source code, one at a time. I think they are important mutators. The first one is a remove conditional boundary mutator. So the replacing higher than by higher and equals or reversed. Because probably in your code, you never test boundaries. Who tests always boundaries? How do you make sure of that? Impossible. So even if you do, which is good, which you should do, probably one can come, one fellow team member can come and forget about it. So either he doesn't know or you have no time. You never can be sure. So this is very, very important mutator. Also something very stupid, but which is never tested, never tested. At least I've never seen it tested, is those void method call. Basically, you can have this assert check not null, because you want to have programming by contract, so you say, okay, I will add checks that the parameters is not null just at the start of my method, right? And so that in the rest of my method, I'm sure that it's not null or positive or I don't know. Then what happens? You have no test for that, meaning you don't never pass null and check that you have an exception. And at some point, someone must pass null for any one of reason, and it's not expected like that in other parts of your code, and you have a bug creeping in. So this is very important, and connection point close, I don't want even to think about it. Also stupid stuff. Checking and testing hash code and equals, because A, the IDE generates it for you, right? And it's true. But then what about when your code evolves? Something that never happens, right? You never add a field to an entity, ever. So if you don't test it, probably at some point it will also break. However, be cautious, because mutation testing is not 100% bulletproof, right? You might, and probably you will, encounter false positives. So again, it's not a stupid number, a metric. You have to really read the reports. Yeah, engineering is hard. That's why we have metrics for manager, but again. Yeah, I love manager bashing. It's so easy. Now it's time for a little demo. Who wants a demo? And the other are playing with their phones or sleeping. Okay, so let's have a demo. So I have my duplicate math. Again, no brainer. 1 + 1 = 2 or not. And my test here. Ready to rumble? So if I test it, so I will go on ASSERT-LESS. Sorry, it's a little too small, right? Better? Who cannot see? Everybody can see? Great. So I will run MVN test. I run my test. Easy peasy. Now I get it. And I go to mutation testing. And I have my pit reports here. But here you can see that I have, hey, guess what? 100% line coverage. And 0% mutation testing coverage. So now you know the trick, right? We add an assert. And I prefer testng over gunit, so. And I assert that the actual object, which is sum, is equals to 2. And now I rerun the stuff. You can see there is a lot more happening behind the scene than normal Surefire plugin. Yeah, you can. No, really, that was hard, right? Now this is quite easy because you can check yourself that there are asserts, right? In one test case. Now the next one is harder to guess because here I created a predicate. So basically, again, it's very hard stuff. If it's below the limit, it returns yes. If it's equals or above, it returns false. Okay? Low pass predicate, right? And in that case, I didn't try to game anything. I was being a good engineer. I was being a good developer, a good unit tester. I've created everything. And here, it works, right? So there are asserts. Now, if I go to the report, now, still 100% code coverage, and in that case, even one test would have achieved the same effect, right? Not the branch, but the line coverage would have been 100%. But here it tells me, okay, you are good, but not so good. So why don't I get 100%, for God's sake? Because I forgot to test the boundary. So I should add the boundary. And here I would say limit. And with that, basically, if I run the same stuff, and I get the results, great. And now you can be sure that if at some point someone decides to change the code, then your unit test will break. And that's what unit testing is for, right? So, however, it's not the only thing that we can do. Sorry. You. Yes, you. But you too. You can do that today for your project if you are using Maven. Remember gradle and ungrading. You can do that very easily. I have taken a project called Yoda Money. Who knows about Yoda Money? Okay, not so many. Who knows about Yoda Time? Ah, much better. So Yoda Money is about money, what Yoda Time is about time. Easy, right? They just try to model currency and stuff like that easily. So what I did is I took the project out of the blue, like that, on GitHub. It's freely available, it's open source. And then I can run my Maven plugin directly. So first, what I should do is I should compile everything and run the tests, right? So I will run the tests. And here we can see that it runs quite easily. So, well, nearly 1,500 tests in 3 seconds something. Great. Now I can run my stuff. Mutation coverage. There is a plugin for that, I told you. Oh no, it doesn't work. And when you read the error message, I have no idea. It seems that it breaks with some tests when you run mutation coverage. Yeah. So in that case, you have to exclude the classes that break. So let's exclude them. And then it will do its stuff. And you see we have 11 test classes now. And meanwhile, if you have any good joke, because it will take time. And time. And time again. So we will get back to that. And this is a real problem at mutation testing. It's very, very slow. You have all synonyms for slow here, right? Ulitka. Как ulitka. So I add some kind of metrics, performance metrics measurement. And basically, if I do MVN clean test compile, okay, so that means that all my classes and test classes will be compiled. Okay, so that's my blank state. Afterwards, I run just surefire test, just the execution of the test. It takes me about 2 seconds or something. And then after, if I run the pit test, 25 times more. And I believe it to be exponential. So the more tests you have, the more you will have. Did it finish yet? Just to check. Yes, 41 seconds here, which is better. So why is it so slow? Because it has to analyze the codes, and for each class on the test, it has to create, and for each mutator, it has to create the mutation, then run the test again. So it's very simple to understand why it's very slow, because it has to combine all permutations. Of course, this is not acceptable in a normal test run. But again, I give you a problem. I try to give you solutions. So there are workarounds around that. Basically, you can limit the mutators that are applied. You can say, I will only use this and this mutator. This is great to reduce the time. This is not so great because, of course, in that case, you will also uncover less probable bugs. You can also set the target classes, the classes that you are very afraid that will break. And that is good because you will probably need to focus on something that is hard to check first. Also, you can set the target tests. You can also, there is something called the dependency distance. Basically, Pit will also mutate the classes that are not in direct relation to your code, but just the classes that are used. For example, if I have a test here that uses a dependency, and this dependency will create a mutant, we say here that on the left, there is a dependency distance of 1, and here there is dependency distance of 2, also very simple to understand. So you can limit the dependency distance, because probably if the dependency distance above 5, 6, I don't know, probably it limits the ripple effect. Probably it won't affect the run of your code. Probably. But you have to check yourself. That's stupid also, I think, but you can limit the number of mutation. So you will apply mutators, and at some point you say, okay, stop, I don't apply any more mutator because I'm done. And don't ask me about the ordering of that. I have no idea. Because I didn't check, because I think this is a bad idea, but still, you can do it. What is very, very important, and that I did that on my first demo, I bound the plugin to my test phase, meaning every time I run MVN test, it runs the plugin too. And that is very stupid. That's good in demo. I don't do something stupid for no purpose, right? That's very good in demo. It gets things done much easily, but you don't want to do that in your real project. Because that means that if you want to test the code you just created, then it will run for ages. That you don't want. You want, on the opposite, you want to decouple the normal Surefire plugin with the test plugin, with the mutation coverage plugin. What is good too is you can use another target, which is called SCMMUTATIONCOVERAGE, not mutation coverage, and basically it will not run the stuff that was not touched. And that is great. There is something which is also not in this slide, in this presentation, but it's very interesting. You can configure Pit to create hashes of test classes and classes, so that if those are not changed, probably it won't run the same stuff again, because the result will be the same. And that is great. The only thing that you have to configure is to put those kind of hashes into a dedicated folder that is not part of your Maven target folder, of your build folder, because otherwise when you clean it, it will remove everything. Do use on continuous integration server, and that is the main point. I mean, on continuous integration server, you can have daily builds, you can have nightly builds, you can have twice per day builds. You don't care, hourly builds. And it might take 30 minutes, you don't care. However, the results from that stuff is of very, very high value. So is mutation testing the silver bullet? Like coverage was the silver bullet, now you've got mutation testing. Now let's all do mutation testing and trust it blindly. So no, I'm sorry. You still have to use your human brain. You still have values of a manager, is that you are engineers and you can interpret the results of this kind of stuff. Because again, there might be false positives. However, it will tell you, and that is very important, what is the real value of your code coverage, especially if you have a high gap between the value of your code coverage and the value of your mutation testing. That's where the danger zone is. Because that means if you have 80% code coverage in one package, you feel safe. And if you run and you have 20% mutation testing, this 60% is a very high. That means probably your confidence in that package should be only 20%. So code coverage, easy to compute, but meaningless. Mutation testing, harder to compute, but better. So use both. And of course, it doesn't prevent you to do all the other kind of testing you need to do for a real application. Like integration testing, like penetration testing, performance testing, everything. So it's not either or, it's one more tool in your tool belt. I would like to conclude with this very simple stuff. Why do you test? You don't test because you want to have a higher code coverage than your colleague. you test because you think that the time that you spend in test will be less than the time that you will need to fix the bugs if you didn't test. So it's only about return over investment. You know, I'm quite old now. I've seen a lot of crap, and I've seen the shift. Like 15 years ago, basically, there was no automated testing. Think about it. No automated testing. Nothing. We clicked around and say, okay, it works. Hey, let's ship it to production. Yeah, that's how we did things at the time, right? And then someone explained to me, someone more senior, because at the time I was freshman, right? Hey, you know what? What we did in our previous project, we tested the stuff in the main method. And that was a huge improvement. So no automated stuff, but still we tested. So you had to run all your stuff and check on the log. Oh yeah, it works, it works. And now we have automated tests. And now the shift is, let's test everything. Let's test the setters and the getters. And come on, guys. You have to use your brain, right? So again, think about return over investment. Again, and the problem is that it's very dependent on your context, on your project. If you are writing software for planes, for example, probably you want a zero bug policy. Probably. If you have an application that runs on iPhone, like, I don't know, Candy Crush, one bug might be acceptable, right? We don't care when we have millions of users that at some point, half of them might encounter a small lag, and we don't care, really. So it's really worth thinking about, is it worth testing or not worth testing? And in any case, probably there are some stuff that are more important than others in your application. So they should be tested first. Business critical stuff first. Also complex stuff first. Because this probably, if it's not well tested, might probably at some point in time add a new bug. So prioritize what you want to test. This is the time for some Q&A. You can follow me on Twitter, you can read my blog, and of course you can buy my book, which is not about mutation testing, but about integration testing, which is still very interesting and I think undervalued. So I think I followed the program. We have 10 minutes for Q&A. I hope, yeah, great. Thank you.
You have provided us with a list of mutators.
Mm-hmm.
Yeah? Is it complete, or if I want to, and it is the second question. If I want to write my own mutators that are mutating exactly business logic, is it possible?
Everything is possible.
Oh,
it will just go through money. No, so the list of mutators I provide you with are out-of-the-box mutators provided by PIT, right? The mutators that will be used in every case. Now there are some more that are experimental, and you have to activate them manually. And of course, PIT is an open source product, hosted on GitHub. So you can write your own set of mutators and let them run too. Now, whether it's a good idea to change your business logic, I'm not so sure. We can discuss about it afterwards.
Thanks.
Other questions? Yeah.
Okay, thank you. So, do you have any examples of using such testing in Hybris or maybe configuration?
Basically, it's not about Hybris. Basically, you just the problem is, first, I showed you with Maven. You know that Hybris doesn't run on Maven, right? It runs on Ant. So basically, probably what you want to do is to configure your on target, which I don't know, to tell, okay, this is the unit test that I want to run with mutation testing, and basically you are done.
Okay, thank you.
You're welcome. Other questions?
Is it possible to configure not via XML, but for example via annotations? For example, I create a test and I want to say, okay, run this test and mutate like underlying classes with this constraint set of mutators.
Short answer is no. Long answer is why would I? I don't understand the stuff that happened with annotation. Really, it blows my mind. I'm a really huge Spring fanboy, and for a long time I prevented my teams, my developers, to use self-annotated class. Because Spring is about the inversion of control. Why would I use annotations that bind me, that couple me to a Spring framework? I want everything to be orthogonal. And likewise, I don't understand why I would need this test to know that it has run under this kind of stuff. Because I might have different configuration in different environments. It would be much better. So I don't want to be this annotation set stuff in stone. I don't want it. So that was my long answer.
The question was also about, is it possible to configure for a particular test a set of mutators? Yeah,
Sure.
like in Maven, you showed in Maven, like I think it's applied to all projects, right? But for a particular test, I want to say like I want.
It's about Maven, right? So Maven, you can configure in the POM, but you can also override it, like I did here, with some system property, -d. So yes, you can do that. You can do that very easily. So you can have your common configuration in the POM, and per run, you can configure with system properties that override or set the values. So yeah, it's possible. But it's for any Maven plugin. You just have to look at how it's done, and quite easily.
I mean, particular test. So I have a test class, right? For
Okay.
like testing add method, tested minus method, and I'm just want to set for this minus method, that testing minus, I want to have constraint. So I need to rerun Maven for this, like with some constraint. So, I want to limit a number of mutators for a particular test. Just
for a particular
Yes,
method,
yes.
no, I don't think you can do that. What you can do is you say, okay, for this run, I will only run this test class, not test method, test class, with this set of mutator. And for this run, I will run another test class with another set of mutator. Again, in my humble opinion, restricting the set of mutators completely destroys the concept of PIT, of mutation testing itself. Because basically, PIT is about exploring all possibilities. If you restrict the number of possibilities, you will drastically reduce the number of potential bugs you uncover. So I wouldn't do that, but you can have two different runs that test one stuff with a set of mutators and another stuff with another set.
Okay, thank you.
Do you hear me?
Yeah. You're a big fan of DIN framework, and probably you have an experience which you can share with us regarding the running or leveraging of benefits provided by this kind of testing on real project like via DIN, or I mean, it's easy to see how it's working with small projects or just sandbox applications. I'm wondering.
Jordan Money is not a sandbox application. It's a real project.
Yeah. Unfortunately, I'm not aware how big it is. Could you please?
Yeah, sure. So 17 number of classes, of test classes. That's not super high, but you can do the same. Probably you don't have, if you have one big application, probably you have different modules. So probably you should run them by module first.
Yeah, probably. And what is your personal
Now
opinion regarding the quality of the coverage of the mutations? Do you think it's acceptable level, or it's worth to fix them?
That's what I told you before.
It's
If you want to have software that assists you in surgery,
yeah,
you cannot have below 100%, really. If you want to run Candy Crush, you don't care so much, because it will take more time, more energy, more money to increase the stuff. And that is a real problem, is that you will have to know that by trying and failing. Because at some point you might say, okay, let's do 60%. And then you will notice that people start complaining, that it gets slower, that it costs money, that your managers start bitching and stuff like that. Or you say, okay, let's do 20%. What I would do, what I did, is basically take the sources of your project, and before just leaving the office, you launch what I did, just the plugin. And when you come in the morning, you're happy, you have the report, you start reading them. It costs nothing, zero, just CPU power, little more electricity, you don't care, basically.
Yeah, I mean, it's definitely worth to try.
And then you
I'm
can
just
check.
wondering, you showed, sorry for interrupting you, you showed that you face it while trying to run this test for Joda, you face it with some errors, and you fix them by explicitly excluding some classes. And I'm just wondering how you figure out that what particular classes you have to exclude.
Oh, because it is said when you run the test, and basically it tells you, hey guy, I'm sorry, but this class doesn't work. Here you see, test big money did not pass without mutation. Test currency unit did not pass without mutation. So I'm not smarter than you.
Yeah,
I just read the error log.
No
problem. I can.
Fast for me.
Yeah, anyone can do it.
Yeah.
Not your manager
I like
again,
it.
but
thank you very much.
anyone in this room can do it.
Okay, can I ask a question too?
Sure.
So, it's about tool itself. Can we see the list of mutants who survived? Is it possible?
Sure. So let me show a real. I've run the reports on Joda Money, and here it's a very easy. So again, the important stuff is the difference between the line coverage and the mutation coverage. So probably you want to start here. We have here 7% difference, and here a little more. So let's go there. And here we have 97, 66. Might be a good start. And in the report, if we go, so here it's line by line, but here you can see exactly the problem, why the mutant survived, and change conditional boundary. So this is about the boundary problem that was not tested. That's very important. You can check where it happened. No, not here, obviously. So here it happened. So there is a test there that does it below 0, but never check if it's 0. And you can see there are a lot like that. So when you take an open source project as a dependency, it might be worth also checking not only the code coverage, but also the mutation coverage, because you want to be sure that there are no bugs creeping in, or they won't be in the future. Does it answer your question?
Sure.
Okay.
Okay, thank you. Probably if
Thank
we
you.
have more questions,
Yeah,
we
you can
ask
come
after.
afterwards, and I will be in here the whole day. No tolka, pa angliski, por falusta.